Welcome to your online tutorial video for section 8.3 in your textbook. We're working on page 315, example 1, solving equations with grouping symbols. Well, grouping symbols, what does that mean? Well, let's look at the first example it gives you in the text. And it gives you 3d plus 0.4 is equal to negative 3.9. So that says that if we had d plus 0.4, we have three of them. So we actually have three D's and three 0.4s is what we really say there. But that's, in order to simplify that, we're going to need to use, according to the solution, method 1, we're going to use distributive property to simplify this particular part and then work from there towards getting our answer. So the first thing we have to understand is because we have 3D plus 0.4s, we need to multiply each term by the 3 because we're following distributive property. That means we have 3D plus 1.2 equals negative 3.9. So all you have to do when you have equations like that is you have to simply decide, okay, I'll expand it using distributive property. Now I've created my equation that just has my constant and my coefficient, and I could just simply isolate the variable like I have been for all eternity. Subtract 1.2 from both sides. I get 3d equals negative 5.1. Divide both sides by 3. And I end up with d is equal to whatever 5.1 divided by 3 is. I think it's negative 1.7. Okay? That's what you could do first. However, there's another way to do it. And if we look at example 2, on the next page on 314, or 316, excuse me, it said method 2 is to divide first. So if we think about what this says, I have 3 of these. If I divide this side by 3, I am using opposite operation to get rid of the fact that I have 3 d plus 0.4s, and now by dividing by 3, I just have 1 d plus 0.4. But because I divided this side by 3, I have to divide this side by 3. I get negative 1.3. And now I have a much simpler equation that's a third the size of it that it was. I simply subtract 0.4 to both sides. I end up with d equals, aha, look at that, the same answer I had before, but in a different way. So what I could do here is what I have to really do is, going back in time here for a second, is I have to acknowledge this is a multiplication of 3 for this part. And by applying opposite operation, if I divided the whole side by 3, I don't need to multiply it by 3 anymore because I end up with the part of my distributive property inside the brackets. Okay? So let's try the example that's on A on the bottom of 316. And let's try both methods. Let's try, we'll call these two methods. We'll call this one using distributive property and not using USING distributive property. Let's see if you can do it both ways. So the equation that you have there is 2 bracket e minus 0.6 equals 4.2. So we'll do it both ways. First method I want you to solve using distributive property, and the second method without, just like we did before. Okay, press pause, give her a go, see how you do. Okay, welcome back. So the first thing we're going to do with solving using distributive property is we're going to multiply both parts inside the brackets by 2 because we're doubling the e minus 0.6. We have to double it. So that means we have 2 e's, and we have 2 negative 0.6, which is actually negative 1.2 equals 4.2. So using distributive property, that's what the brackets simplify to. I then add 1.2 to both sides. I end up with 2e equals 5.4. Divide both sides by the coefficient, and I end up with e equals 2.7. Aha, that was so easy, you say. But over here, it can be even easier. If I acknowledge that this is e minus 0.6 and I doubled it, by dividing it by 2, I only have 1 e, take away 0.6. And, oh, don't forget to do it to both sides, Mr. McDonald. Oopsie daisy. I end up with 2.3. I add 0.6 to both sides. And I end up with e equals, look at that, 2, oh, a different number. What happened there? Did I make a mistake somewhere along the line? Oh, that's what I did. Look at that, I put 4.2 here and 4.6. Well, let's pretend this is 4.2 instead. I would have ended up with half of that is 2.1, and 2.1 is 2.7. So I would have the same answer using this non-distributive property method. A very valuable tool is what this example is teaching you. So please use it wisely. Okay, let's go back and look at the second example. Okay, now this one doesn't allow you to use the second method so much, but we can use the same one that we learned in the last section. So if we look at c plus 2 over 3 equals negative 5 over 2. Now there's a whole bunch of methods that we can use for this one. Now if we think back to the last section, what did we do? Well, we multiplied both sides by common multiples to create equations that didn't have fractional parts. So if I multiply both sides by 6, multiply this side by 6, and multiply this side by 6, I will end up with a equivalent fraction that's 6 times larger than it was, but the variable doesn't change its value. So I should actually get rid of the brackets here for you. Show it this way. So I'm going to multiply both sides by 6. So if I multiply the tops, what happens here? If I had just two fractions, I'd have to do 6 over 1 times. I'll do it up here just so you can see it a little bit better. I'm going to multiply the tops. Now remember, if you multiply a monomial by a binomial, you have to follow distributive property. So I'm going to end up with 6c plus 12 over 3. That's my answer. And I could reduce that. But if I look back here, I could have cross-reduced it to get 2 over 1. And I'll just do it over here. What I end up with is 2 times c plus 2 over 1 times 1, or 2c plus 4 over 1. And that's actually what this is going to reduce down to, because of the fact that I'm going to divide both terms of my binomial of my numerator by 3. 6c divided by 3 is 2c. 12 divided by 3 is 4. So we get the same answer either way. So 6 over 1 times c plus 2 over 3 works out to be 2c plus 4 over 1. Over here, if I cross-reduce, I get 3 over 1. I end up with negative 15 over 1, or just negative 15. Again, by multiplying both sides by 6, I created an equivalent equation that does not have any fractional parts to it. I would then subtract 4 from both sides. 2c equals negative 19, divide by 2. I get x equals negative 19 halves, or negative 9 and 1 half. Okay. Let's look at that same equation, see how much I'm going to have to erase here. Let's look at that same equation, but instead of multiplying both sides by 6, let's see if there's another way to do it. Oops. Getting there, almost there, and there. Instead of multiplying by 6, what else could we do? Well, we could have multiplied both sides by 3. That would have worked as well. I would end up with c plus 2 equals negative 15 over 2, which would have been subtracting 2 from both sides. I would have been c equals, okay, how does this work? This is going to be negative 4 over 2, or 4 over 2. And that's going to be negative 15, take away a positive 4 over 2, which is going to be negative 19 over 2, which is the same answer that we got before. So there's another way we could have done it. We could have just isolated the variable using our known methodology. Now let's go back here and look at a different way. What if I was to look at this as proportions, and I was to cross multiply to create a new equation? That's actually going to be the same thing as multiplying by 6, but we'll see that in a second. So what I could do here is I can multiply 2 by c plus 2 and get 2c plus 4, because remember I have to use distributive property. All right, that's 2c plus 4 equals negative 15, and that's the exact same equation that we had before. Subtract 4, 2c equals negative 19, and I end up with the same answer that I had before. All right, so there's a whole bunch of ways you can do that. For my recommendations, if you have that, I kind of like just multiplying both sides by 6 or multiplying both sides by 3. Both work, but remember, as long as you maintain good algebraic form, you're bound to go right if you understand. Whatever you do to one side of the equation, you do to the other, it works out fine for you. Okay, if you have any questions about section Page 316, don't hesitate to come see me. I'm here to help. Remember, extra help classes are Tuesday and Thursday after school until 4. If you need any more extra help, let me know.